Okay, so we're going to learn a bunch of vocab today about angles and how you can go forward or backwards with angles. And then we're going to be doing reference triangles. But I feel like you need to understand why we need these reference triangles. And so I'm going to just go back to a couple things that by reviewing them today, it'll make your life easier later. Today, it'll mean more stuff to learn today, but you're going to have to know these things. Because I'm betting that you're like last hour, and not many of you are going to remember the 30, 60, 90 triangle and all the sides that go with it. So everybody copy that down, just write 30, 60, 90. It's a classic right triangle that you use in geometry, and then you learn the side ratios. Lux, can you remove the headphones for now? Thank you. So these side ratios are huge. We're talking huge. Like you're going to use them at least 100 times. Seriously. You will copy this and make this triangle 100 times between now and the end of the semester. Because there's so much trig. The whole second semester is basically a trig class that used to be 1 year long. Okay. Do you know what these three numbers are? Raise your hand if you do. I would love to have one person who knew these. All right. So I think you're seeing that nobody's raising their hand, and that means maybe somebody thinks they might know, but they're not confident. All right. So write these down. This side is 1, this side is 2, and this side is, well, I like to say it's as easy as 1, 2, 3, but can you use logic and go, why can't this be 3? It's not the hypotenuse. The longest side would have to be the hypotenuse, so that can't be 3, but it can be the square root of 3. At least tell me you feel like you've seen these numbers before. Yes? Okay. They were in geometry, and this is super critical. Like if it was legal to have a tattoo, you guys are actually too young to actually have it. Well, some of you actually might be legal to have a tattoo, but if you had this tattooed on your hand, it would be a huge help in math class. I actually wonder what you would do if a kid tattooed an important formula on their hand that gives it an advantage. I've never had that. My guess is you'd have to have a bandage over it during the test. But anyway, I'm not suggesting anybody's going to get this for a tattoo, but I'm saying you're going to use it over and over and over because we'll expect you on the test without a calculator to tell us what the sine of 60 is. And there's nobody in here who's going to have this memorized. But if you have this memorized, you can figure out the sine of 60. So would you please write down sine of 60? And then you're going to go back to SOHCAHTOA in your head. SOHCAHTOA was one of the 20 things I reviewed yesterday. Because to get sine, you need to know SOH, S-O-H. From the 60s perspective, which one is the opposite side? That one's the opposite side. Over hypotenuse. Well, there's only one hypotenuse. What's the hypotenuse in this case? 2. Do you get how I got square root of 3 over 2? Do you get how I got that? It was the opposite over the hypotenuse. From the 60s perspective, the opposite one was like across the street. I want to talk about that for a minute. Let's say that you live here and somebody else lives next door to you. They are called adjacent to you. The house adjacent to you. They're right next door. The house opposite you is like you go across the street, and that's where the house opposite you would be. So opposite means like across from. Adjacent means right next door. So when I say opposite, from this guy's perspective, opposite means you go across the street here and use that side on the top. And adjacent means right next door to you. Why? I just did the wrong one. A hypotenuse. Sorry, this one's the hypotenuse. Sorry. And the hypotenuse is this one, the longest side. This one would have been the adjacent side. Okay, so there's the 30, 60, 90 triangle. We're going to spend a little more time here because this is so important. Would you please figure out the tangent, which is TOA, of 30? So you go to the 30, use its perspective to figure out what's opposite and what's adjacent. And your answer is a fraction. Tangent, total, opposite, over, adjacent. So from the 30s perspective, right here, opposite, 1. Over adjacent, adjacent is this one. The other one's adjacent, kind of, but it's the hypotenuse. So you can't use the 2, that would be the hypotenuse. 1 over the square root of 3. Raise your hand if you had that one right. Okay, cool. So now I want you to go to a blank page or a blank space on your iPad so that you can't see that triangle anymore. And do you get, if I said, what is the cosine of, let's see, what did I just ask a second ago? I asked sine of 60. Let's do cosine of 60. You'd have to make that triangle from memory and figure out what side goes where and give me the fraction answer. Cosine of 60. Everybody try that. Make a fresh new triangle. And this is like the basic trig. It's called right triangle trig. It's on the ACT, and it's used in this class all the time. Second semester. Sabins, did you make a 30, 60, 90? What's the key angle in this case? There are 3 angles. Which one's the key one?
60.
The 60. And from that 60s perspective, we're going to need to know 2 things. Cosine is ka in the whole SOHCAHTOA thing. So what are the key ones we're looking for?
The adjacent and hypotenuse.
Excellent. Adjacent and hypotenuse. Now I got to know where the numbers go. The smallest one goes across from the smallest angle. If you're wondering which one is the one, think about it. The smallest angle, smallest side. The biggest side is a 2. I know 2 doesn't seem very big, but it's twice as big as the 1 is. And the third side is the square root of 3. I think it's almost as easy as 1, 2, 3. 1, 2, square root of 3. Does that make sense so far? Okay. Now, Turf, can you tell me cosine of 60? Would you agree it's adjacent over hypotenuse?
Yeah.
So, from the 60s perspective,
Adjacent would be 1.
yep,
Hypotenuse would be 2.
you got it. 1/2. That makes sense to you? All right. That's called right triangle trig. Now, there's 2 key ones, 30, 60, 90, and this other one, 45, 45, 90. Everybody draw a triangle that is called isosceles. And that means 2 of the sides are equal. And that means because it's a right triangle, one of the angles is 90, the other 2 have to be the same angle. Because these are the same length side, here and here, these angles have to be both 45. And you're supposed to have this one memorized. They say that after about 10 minutes, your brain is a little warmed up to math. We're about 10 minutes into class now. Maybe somebody got this one memorized. Do you remember the sides on this one? They're nice simple numbers. What do you think?
That's 1, 1, and root 2.
You are correct, sir. 1, 1, and root 2. Now, I want to give you some logic why we could have known that it was going to be 1 and 1. Do you get that we're picking sides to be as small as possible? We are picking the simplest, smallest numbers. And would you agree 1 is the simplest, smallest number? Okay. Well, then 1 had to be one of these sides. And if there's 2 sides that are going to be equal, why not make them both 1? And then you could use logic to figure out what this one is, because a squared plus b squared has to equal c squared. And you take this one squared, which is still 1, this one squared, which is still 1, and then this one would have to be the square root of the other 2 added together. Square root of 2. All right, that's just a really quick reminder that you could use a squared plus b squared equals c squared to get these. But now that we've got these, I could ask you on the next test, and I will. Won't be this exact question, but what is the sine of 45? you draw this little triangle, and then it's easy. As long as you know what SOHCAHTOA means. I'm a big one on believing in working a little harder early so that your life will be better later. And that's what I'm doing right now. We don't have to know these for today's homework, but you are going to need to know it on a future day. And by previewing it today, a couple days from now, you'll be like, oh yeah, that's easy. Whereas that day would have been brutal. So I'm taking a day today that could have been an easy day and reviewing all this stuff to make your life better in a couple days. Now, same idea with the whole basics thing. Your top 20, first 20, those kinds of things. If you get those down early in the year, which I know a lot of you did, you fixed a lot of mistakes you had on the basics. That helps you so much later. So we're doing that today, making life a little harder today so that later it can be better. All right. Sine is opposite over hypotenuse. Which 45 should I pick though? It doesn't matter. If you do it from this 45, it would be opposite over hypotenuse, which would be 1 over root 2. If you do it from the other one, it's the same exact answer. The opposite would be this one then, over the hypotenuse is root 2. So there it is, either way. All right, let's just do one more. What's tangent of 45? Well, don't redraw the triangle. You already have it. Yes. It's just 1. TOA is opposite over adjacent, 1 over 1, which is 1. Okay, cool. Now that's basic right triangle trig. And I'm not dumb enough to think that everybody would get every problem like this right, but at least now most of you pretty much remember this. So let me explain why we need these reference triangles that you're going to be drawing today. Because I don't want you to just like show your reference triangle and you're like, I don't know why we drew those things. Let me explain it. If I was going to ask you to find sine of 120, do you get you could not draw me a right triangle for a 120 degree angle? Think about that. There's no way to make it have 120 degrees on one of the angles and still have it to be a right triangle. There's no way to do that. Do you get what I mean? So you have to not just do what you did in 8th grade. You seriously did these same problems in geometry whenever you did it, 7th, 8th, 9th grade, something like that. You already did that. So in trig, which is part of precalc, we need you to be able to do things like sine of 120 without having a triangle that has 120 in it, because there's no way to do it. So then how do we do it? Well, let me show you. If I wanted a 120 degree angle, you always start here. Okay. And we actually have a slide for this. So everybody go to slide 2 here. The initial side is always going from the origin, you know, like the middle of the X and Y axis. And it goes out this way. That's called the initial side. You always start there to create your angle. And then you swing up this way and you stop somewhere. And let's say you stop there. To me, that looks bigger than a 45. And so it's probably the most common place to stop that's just a little bigger than 45. Anybody want to guess what this angle probably is? 60, I agree. So let's put a 60 in there. That's making a 60 degree angle. Now, spoiler alert from a future slide, this is another way you could go 60 degrees. You could go in the negative direction and you could make a 60 degree angle by stopping there instead. And that's also 60, but it's negative 60. You can go in the negative direction to get angles. Okay? Just negative is changing our direction. All right, so let's go back to this one. That's a 60 degree angle. So if I asked you to do what is the sine of 60, right in here you could go, well, I guess I could make a triangle out of this. I don't have to draw a new one. I can just go boom, 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 and it's a 30, 60, 90. See what I mean? And if I asked you for the sine of 60, you go, okay, well, let me think. Where's the 30? That's up here. That's the 30-degree angle. I should probably put it in here. That's the 30. That's the 60. And then I can do the 1, 2, 3 thing. Except it's 1, 2, square root of 3. This will be 1. This will be 2. This will be square root of 3. And then I can get sine of 60 would be opposite over hypotenuse. So it's square root of 3 over 2. But that's if it's normal. And again, you already did that. You already did that in 8th grade. So what I just needed to remind you how that worked so that now we can do angles that are much bigger than up to 90. We can make triangles that have like a 120. So if I was going to do 120, would you agree it would go past 90 here by 30 degrees? See what I mean? Do you get that's 90, and then 120 would be like 30 more than 90. Are you with me so far? Then I'm going to scribble this out, and I'm going to scribble this out, and I'm going to just have you focus on this. I'm going to make it red, this red line here. That's where the 120 would be. If that's 120, then I can make my triangle here. And that is a normal 30, 60, 90 triangle. But you might be saying that doesn't include the 120 in it. No, it can't. We can't draw a right triangle that has 120 degrees in it. So we draw one to refer to, and it's called the reference triangle. So one of your questions on your next test will be something like, can you make the reference triangle for 120 degrees? Not saying it's going to be 120. It could be, it'll be something more than 90 though, right? So it might be like 180, or it might be like 200 and, maybe it's 300 degrees. All right. So if I have this 30, 60, 90 triangle now, would you please take a second, draw what I just did, and then put in the 30, the 60, and the 90, and then put in the numbers. That's called the reference triangle. It has to be all labeled. It can't just be this triangle. It has to have like what's here, how many degrees is here, and 30. That's a 90. You can put a little box for the 90. This one's 60. And hopefully by now those numbers that are easy, almost as easy as 1, 2, 3, are slapped in there. This side's 1, this side's 2, this side's square root of 3, but this is the most common mistake. I did something wrong. It's little, but does anybody know what I did wrong? It's going to be the most common mistake you will make on your tests too. I call it the most common mistake of circle tree. Do you have any idea what's wrong with this answer? Yes?
The square root of 3 and 2 on the right sides.
Good question. Nope, I didn't actually screw that up. The 2 is on the hypotenuse, and it's supposed to be, and I get how that's confusing sometimes,
yeah.
but no, that's not the mistake. See, if nobody in here is catching it, it must be something kind of subtle. And it's the most common mistake in circle trig, and that is that when you're in 2 dimensions like this, this side is now -1. Why? Because it's going from the origin to the left. If I asked you to graph -1 comma something, you would have known to go to the left. It's easy to forget that, isn't it? And you've never had triangles that had negative sides before. Well, welcome to precalc. It's harder. But I think you can handle it. It's not that bad. There's only one side that went to the left. Why isn't this negative? Because it went up. Do you get if it would have went down? It would have been in the negatives. All right. So what we just drew there was called a reference triangle. And it has 3 angles, because every triangle does, but only one of them is called the reference angle. Have I said this enough times that you guys can kind of tell? Is it the 30, the 60, or the 90 in this case? It's the 60. Because it's the one by the center. I called it the central angle. That one is the boss angle. Why? Because that's the one you'll use to do sine, cosine, or tangent. So again, I'm trying to explain, instead of just saying, draw this triangle, I'm trying to explain why we need the triangle. It's because if I asked you for the sine of 120, you wouldn't be able to do it directly, but you'd be able to make this reference triangle and then use this key angle instead and do sine of that. So let's do sine of 60. Sine of 60 is opposite over hypotenuse, root 3 over 2. But you just did sine of 60. Yes, I did. And it stood in for it. Instead of using 120, which we couldn't use, this one stood in for it in its place. It's kind of like, I don't know if you've ever heard of this, but in the military, sometimes there'll be a guy, typically it's a guy who's overseas, and he is falling deeper and deeper in love with his girlfriend who's back home, and they decide to get married. But he's in like Kuwait, and she's back in the United States. They can have a marriage in the United States and have somebody else stand in for the groom, so that he can be like on Zoom, and they can have somebody else stand there so that they can be married even at a long distance, because the one person is standing in for the other. All right. On a much sadder note, Jay Leno recently had to file to stand in for his wife because she now has dementia, and so he's filing some kind of a legal thing to be able to stand in for her and make decisions for her because she's got dementia. Standing in for, being in the place of. If someday you guys are going to be like 50 and your mom and dad are going to be really old, and you might have to take what's called power of attorney, which means you are standing in for them, and then you can make decisions for them. Like you can pay their bills for them. You can decide things like, you know what, I think we should sell the house. And you'll be the one, when you're older, who will have to help out mom and dad when they get too old to make those kind of decisions. That's called power of attorney. There's many times when something stands in for somebody else. Well, this is what's happening with this angle. You can't use the 120 because you can't make a triangle for that. Instead, we're going to have this 60 stand in for it. And that's called the reference angle. And now I can do sine of that, which was opposite over hypotenuse. All right, there's the big picture. And I think we've gotten to it so that the rest of it, I think, should make sense to you. I did hint at negative angles. You remember what I was talking about there? Like this angle. Everybody zoom in on that one. That angle's called a negative angle. I can tell it's bigger than 90. I feel like that's a 45-degree angle. Would you guys agree that that's probably like a 45? And that this one's also 45? And so then that's setting me up to make this triangle right here. And that's called the reference triangle. Everybody draw that and label all the sides and angles. And don't make the most common mistake in circuitry. Did you realize that this was the 90 and this was a 45 and the other one was also a 45, and that's the 1, 1, square root of 2 triangle? Who got those right? Who was smarter than me, actually? Because you did it even better than me. So then nobody caught the most common mistake in circuitry. Do you know what I'm talking about? Negatives. -1 and -1. You see how easy that's going to be on the test? I'll keep pounding on it to keep reminding you. But those are in the negative direction because it goes from the origin, it goes left, which is negative, and it goes down, which is negative. Just to clarify, the hypotenuse is defined as never being negative. Because I kind of get how would you judge whether that's negative or not? So the hypotenuse, the line that goes out here, I'll make it green. This line here, that will never be negative. Never is a big word. We don't ever, in this unit anyways, consider what could be a negative radius. There's a way to do it. You probably won't do it until BC calculus. All right, so now if I asked you, this angle in the first place must have been 90 plus 45 is negative 135. So what if I asked you, what's the sine of negative 135? You would go, I respectfully decline to do that because instead I'm going to have this stand in for it. And the sine of 45, this 45 right here, it matters which one because some things, the negatives will be in different places when you draw these in different quadrants. So it's not just the sine of 45, it's the sine of this 45. And so then sine is opposite over hypotenuse. So what is the final answer? I'm going to use the dice of destiny. What would have been the sine of negative 135? Row 5, last person. Amy, what do you get? Sine is opposite over... Yep. Negative 1 is opposite over hypotenuse, which is square root of 2. There you go. Does that make sense to you? Cool. We just did 2 days of math. Because all you were supposed to do today was draw those reference triangles. But I needed to show you why you needed to draw them. Because otherwise I'm just having you do this abstract thing and you don't even know why you're doing it. So you're doing these triangles so that you can do sine, cosine, and tangent on them. All right, let's go on to the next page. Which ones are positive and which ones are negative? Well, that's easy. That's positive because it goes in the normal direction. That's negative because it goes in a not normal direction. Look at number 3 and be careful. You can tell if you use logic which way they went and therefore whether it was positive or negative. If you look close, you'll see it started here and went that way. Is that going the positive or the negative way? Say it. That is the positive way because it went up first and that's positive. That's the positive direction. It started that way. So this one was positive. How about down here? They call this standard position. Which angle is in standard position? That is something that we're not going to test you on. And I'm not going to worry you with standard position. We'll talk maybe about that on a different day. We have enough things to talk about today. All right. Today will be based on learning off of what we know about the unit circle. Well, this is probably the last piece that we've got to review today, and then we can be done and just work on the homework. Because I think some of you would not have known that that was pi over 2. I hope that everybody would have remembered that that spot is pi and that it's 180. Because I said if there's only one thing you remember, you need to remember that pi is 180 and that they're over there. So that it isn't a huge leap to go, well, this is halfway there, and so it's half of pi. 1/2 pi, I like to say it this way. 1/2 pi. This is 2/2 pi. This is 3/2 pi. See? And if I just keep counting like that, this is 4/2 pi. But you can simplify 4/2. What's that? It's really 2, so it's 2 pi. Does that make sense? 1/2 of the way to pi. 2/2 of the way to pi, which, yes, simplifies to pi. 3/2 and then 4/2. See, the reason that this matters so much is that we're going to be just hitting you with things like, go to 2 pi over 3. And you'll be like, well, where the heck is that? Where the heck is 2 pi over 3? All right, everybody, let's do that. Draw me one of these. I said we'd do about 100 of them. I only have 99 left. 2 pi over 3. So to me, the logical thing is to figure out where 1 pi over 3 is, and then double that. Where the heck is 1 pi over 3? I always go back to that's where pi is. And if I want to go to 2 pi over 3's, first I'm going to go to 1 pi over 3, and then I'm going to go twice that far. So where is 1/3 of the way to pi? You get that? Then I can just double that, and it'll be 2/3 of the way to pi. Well, 1/3 of the way to pi is about there. Do you get that made like a 60-degree angle? Does that make sense to you? That's where 1/3 of the way to pi is. But you said to put 2/3 pi. Okay, so that's here. Twice that much. That's like 60. That's like 120. And that leaves me one more of those, which is another 60 over there. So here's 2 pi over 3. You have to be able to find that spot without me, because the typical test question would be, find the sine of 2 pi over 3. If you don't know where 2 pi over 3 is, you can't do it. Okay, so there's 2 pi over 3. Now, I taught you how to make a reference triangle. Everybody do that. Make the classic right triangle out of that line. That line is the hypotenuse of the triangle. I am almost done here. Stay with me for just 5 more minutes. If you can focus for just 5 more minutes, we'll be doing a nice little easy worksheet for your homework for tonight. All right, 2/3 of the way to pi is right there. And then, ba-doop, ba-doop. If you're wondering, but I made my triangle differently, you can't. You can't. You can't go the other way. I know there's another way, but don't do it. It'll mess you up big time. So here's how you decide which way you can go. After you've drawn this, the way I like to think of it is now you drop to the x-axis. You have to go down here. I know I'm not even going to draw the other one because I don't want it to stick in your head. There's another way to draw it, but it would be wrong. Okay, so then you drop to the x-axis, and then you complete it, and that's a right triangle. But on the test, I can't accept this because it's going to say draw and label, which means, do you know, is this the 30, 60, 90, or is this the 45, 45, 90? And then put the sides on it. Everybody do that if you haven't already. You may have drawn the triangle in the right spot, but you have to label it. So, everybody label all 3 sides. And watch for the most common mistake in circle trig, and then in a second, compare with the kid next to you. Pausing for a second, give that a try. Let's see how you did on this one. 2 pi over 3. I hope you knew that the fundamental thing this was based on is 60-degree angles. Because it was the 1 pi over 3, that was a 60 in the first place. Another one, that was another 60. That made 120. That means this one was the 60. I get how you might have thought it was 30, but it wasn't. This one is 30 up here, and this one's the 90. That makes this 1, 2, square root of 3. Always go through and look, and is there one that's negative? And there is. It's that one. How many of you remembered without coaching that that was negative? Excellent. All right. So easy to forget that, isn't it? And then if they had asked you sine, cosine, or tangent, this would have been the reference angle. Because you could have used the 30, but that would have been wrong. The one you needed was the central angle, which is the 60. That's called the reference angle. RA. Okay, so let's get to this worksheet that we have for today. On problem number 1 of the worksheet that you have in front of you right now, it says label all the called out angles in degrees. So I'll help you get started. It's easy to get these confused because you might think that they're all at, like, if you go 30, 60, 90, I hope you'll be like, wait a minute, that's not where 90 is. So that can't be right. The first one is 30. But this one goes and divides the main angle here exactly in half. So what's that one that goes right there? That's a 45. That makes the next one 60. And then this one's 90. Do you get how that's 30, 60, and 90 with the 45 down the middle? And then, but there's more. Then get used to not counting by 30s. I would do all of these first, and I would skip over these because they're harder, because it's harder to count by 45s. Counting by 30s isn't that bad, because it's like 3, 6, 9, 12. It's actually 120. 15, actually 150. This one's 180. And this one, counting by 45s, you can do it, but it's not that fun. 45, 90, what the heck is that one? 100 and something. 135. Now, are these that important? Yes, because our triangles are called 30, 60, 90. You've got to know where the degrees are. But even more important is the radians. Just because the radians are harder for you, that's why it's more important. Everybody go to number 2. If I was only going to have one of these go well for you, it would be the pi over 6s. Because the pi over 3s are just double that. So it's not that hard to do those because there's less of them. So here's the pi over 6s. For number 2, it says label all spots pertaining to pi over 6. The first one is this spot. It's like a 30-degree angle. Pi over 6. The next one, you skip over that middle one and you go to 2 pi over 6. I'm totally okay with you writing that. I know it needs to be reduced to pi over 3, but I'm fine with you writing 2 pi over 6 because that makes this easier to count. 3 pi over 6. Again, I know it reduces. I would leave it as 3 pi over 6 so that you can go to the next one and say 4 pi over 6. Do you get if I reduce them, it's not going to flow so nice, but if I just leave them, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. That one doesn't even reduce. And then this is 6 pi over 6. Sure, at the end, you should go back and simplify them a little bit, but this is so much easier than trying to simplify them as you go. 7 pi over 6. 8 pi over 6. Just keep on counting just like that. And then just reduce it at the end. All right. I have to count on you to go through and finish this thing yourself. Do number 3. If you don't know where pi over 3 is, for number 3, I know where it is, of course, but I'm just going to remind you how to find it. Pi over 3, pi is like 180. If you get stuck, just go like, what's 180 divided by 3? That's 60. Oh, so really pi over 3 is really 60s. Yup. That's what pi over 3 are. They're like 60s. So 1 pi over 3 is like 60 degrees-ish. It's like that. And 2 pi over 3 is like 2/3 of the way to 3 pi over 3, which is over there. I think you're getting the idea. Now, on the back side, everybody flip it to problem 5, and I want to do one like that, and then you can do the rest. I'm telling you, you need to keep up with me. This worksheet, you need to do it tonight. It's going to make a big difference in your understanding. If you just practice it a little bit tonight, you're going to take what is the hardest semester of precalc and make it easy if you get your basics. All right, so on number 5, it says, draw and label a reference triangle corresponding to 2 pi over 3s. To me, to find 2 pi over 3, I go to where 1 pi over 3 is first. 1 pi over 3 is 1/3 of the way to pi. Oh yeah, it's that spot. But that's 1 pi over 3. I need to go, oh yeah, 2 pi over 3, that's going to be about here. See how I figured out where it was using 1 pi over 3? And then your triangle gets drawn. Doot, 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 doot. Right triangle. Put in your 30, your 60, your 90. We're in the last 10 minutes of class, so I'll let it slide. All right, so label this thing with the sides and the angles, and if this was 60, this is a 60, and then this is 30, and then this is the RA. Please somehow call out that that's the reference angle. If you just draw the triangle, you got so close, but they're gonna say, tell me which one's the reference angle, and it's that one. It's called the central angle. 1, 2, square root, 3, which one's negative? That one is. Yay, there's my answer for number 5. That is called drawing the reference triangle. All right, so I hope you enjoy the break from normal assignments, just a worksheet. You will be handing it in tomorrow. Hopefully you just do it and check it with the answer key that I am going to do and post. And that's all I got for you for today.